Hello, I'm making this video today because someone on the Onshape forum was trying to model this locking mechanism for the breech of an air cannon, where this pin would slide and then rotate and lock in. And to create this slot to model it properly is actually a little bit more tricky than it appears. As you can see, he tried to do this with a straight extrude and it's not quite right, so he was looking for some tips. So I'm going to show you how I did it myself. And this is the finished result. If you look at it carefully, you can see that the faces are all tangent and smooth. The slot is a uniform width all the way through. You can pass a cylinder down the one slot, around the helix, and into the other one smoothly without any interference. What you're really simulating is the movement of an end mill through the solid, cutting away as if you passed a cylinder through this path. So the trick to doing that, I'm going to back up a little bit here, is to fairly straightforwardly model the two slots and then create a helical sweep between the endpoints. And there's a certain way you have to do that to get the surfaces to meet up properly. Let's see here. What we need is a helix between the center points of those two rounded ends of the slots. So I did that by creating a cylinder, because with Onshape you create a helix by selecting a cylindrical surface. And the cylindrical starts at one endpoint and stops at the other endpoint, right at the center. Now it's a little bit tricky when you create this helix to define it. The start position or start orientation is not really definable. There's no way to define the 0-degree reference for this, so you kind of have to monkey around with it. I ended up having 80 degrees or 180 degrees getting us to this point right here. So I adjusted it a little bit. You can see it's going to turn on me. So I want that there. And that was just mostly trial and error. The number of turns, since I have 45 degrees between these two slots around the axis of the cylinder, I made this an eighth of a turn, which is equivalent to 45 degrees. So that got me my helical segment here. I'm going to turn off that cylinder just so we can see a little better. Now once I have this path, very important is to create a plane for your profile sketch that is at the endpoint and normal to the helix at that point, and right through the center of that circular endpoint. And then it's just a matter of creating a rectangular sketch. Once again, as you can see, it is centered on the path. This is constrained right to the midpoint. It's tangent to the circle. It's the same width as these slots. Once again, it's on that plane that's normal to the helix. And then it's just a matter of creating a sweep of that profile along that path. And that gets our cutout. As you can see, since it's at the proper angle here and it's already tangent, it will start out tangent and smoothly sweep along. And since the endpoint is also positioned correctly, it will join that slot smoothly. And as you can see, if you can imagine the cross section of a cylinder that you just passed along this path, cutting away, you can see that it makes the proper geometry. If we had created a sketch in a plane that was parallel to the axis here, you could see that the slot would be not as wide as it needed to be, and it wouldn't meet up tangent properly here. So that's how I did it.